Welcome to this explainer. I am absolutely thrilled to share this with you today. A lot of people just assume that artificial general intelligence, AGI, is ultimately going to be built on massive, endless oceans of big data and language processing. But what if we've been looking in the wrong place entirely?
Think about it. What if AGI actually begins with the brain's absolute oldest intelligence pathway? We're talking about visual cues, physical exploration, and gaze. It's a completely fascinating premise. The idea that true intelligence might not start with words at all, but rather with how we visually interact with the 3D world around us.
Okay, let's dive right into this. Here's our roadmap. We're going to hit the question of intelligence, our biological blueprint, AI's visual shortcuts, context through digital twins, distributed collaborative intelligence, and finally, the super way to AGI. Let's get started.
Section 1. The question of intelligence. When we think about the human brain, it's absolutely crucial to realize that it doesn't just passively process the whole world equally. It doesn't take everything in at once like a sponge. Instead, the sequence kicks off with interaction. An organism meets the world, and the world pushes back. That interaction instantly triggers exploration, and from that exploration we get highly focused attention. But attention doesn't look everywhere. It actively narrows the field down to find relevance. It's constantly asking, where's the meaning? Where's the risk? Where's the opportunity?
Moving on to Section 2, the human biological blueprint. To really understand this blueprint, we have to look closely at how this directed attention actually commands our physical sight. We aren't just standing there letting light blindly hit our retinas. We are actively hunting for information. First, our gaze selects a general field. Then the fovea, which is the supersensitive center of our eye, sharpens that specific selected cue, giving it ultimate high-resolution priority. Finally, we have saccades. These are those rapid, jerky eye movements that continuously jump from cue to cue. Your brain is not a passive video camera. It's an active, relentless hunter building a dynamic path through the visual world.
But here's the catch. Those visual cues don't instantly magically become intelligence. There is a vital middle step here called affordance. Think of affordance as your brain's rapid-fire cognitive evaluation of what possible actions a situation allows. Before you ever make a conscious prediction about the future, your brain is already asking, what can be done here? Can this thing be touched? Should it be avoided? Can I eat it? Should I run away from it? These possibilities act as powerful attractors, literally pulling our neural system toward potential meanings and actions.
So to put that into a really simple perspective, a passive camera just sits there recording flat data. Our active biological brain does something far more complex. True intelligence isn't just about recording what happens to be in front of you. It's about actively guessing the future in relation to a specific action, and then using real-time correction and learning to refine that guess. Section 3. AI's visual cue shortcuts.
Now, what's really interesting here is how this entirely biological concept crosses over to the digital track. You see, AGI doesn't actually have to perfectly replicate every single biological quirk of the human body. Instead, it can just mirror these specific visual shortcuts to become incredibly efficient. But shortcuts require structure. They absolutely need context, not just oceans of flat data. Enter HSML, or hyperspace modeling language. This is the critical foundational layer that prevents AGI from just getting totally lost in the noise. It gives a logical 3D structure to these visual cue shortcuts, representing people, places, and things in a way that actually means something.
Section 4. Context through digital twins. This HSML logic we just talked about, it isn't some empty grid. It is actively populated by objects represented in 3D space, which we call digital twins. A digital twin carries a specific place in 3D space. It maintains relational context, it updates its state in real time, and it tracks dynamic change. So imagine a digital twin of a person walking across a room, while the digital twin of a door swings open, and a coffee cup sitting on the table changes its state from full to empty. This constant real-time updating gives intelligent agents a continuous, rich, and meaningful understanding of an ever-changing world. So, the absolutely crucial point is right here. With digital twins and HSML, AGI fundamentally shifts gears. It makes this massive conceptual leap away from merely matching static data patterns and steps into actually reasoning through a structurally changing dynamic world. It's a total game changer.
Section 5. Distributed collaborative intelligence.
So, what happens when you scale this up? When you have millions of these digital twins and intelligent agents interacting all at once, you get the spatial web. And to make that massive, complex interaction actually work without breaking down, we need a secure communication line. That is HSTP, the Hyperspace Transaction Protocol. Think of HSTP as the ultimate exchange protocol that turns isolated individual machines into a deeply connected collaborative network. It seamlessly carries world models, context, and intention between intelligent agents.
Because here's the thing, complex intelligence doesn't just spontaneously emerge from one massive, monolithic viewpoint. Just like the human mind emerges from millions of interacting neurons, AGI emerges from multi-scale combinations of simpler intelligences. Each localized frame of reference, shaped by its specific experience, its position, or its task, aggregates into a comprehensive whole. And it does this without losing its unique individual shape.
As the brilliant saying goes, diversity is not noise. Diversity gives the collective system selective advantage. By preserving these unique, localized viewpoints, we allow for deep, rich knowledge aggregation. It creates a collaborative intelligence that is totally transparent, incredibly scalable, and actually uses difference as a profound strength rather than just trying to erase it. Section 6. The Superway to AGI. Let's bring the biological brain and the digital network together right now and look at the parallel paths. On the biological side, we have the brain's natural flow, moving from interaction to visual cues, straight through affordance and attractors, and finally landing on prediction and learning. Right alongside it, the AGI flow takes those same visual cue shortcuts, applies HSML logic, leverages the spatial web in HSTP, and results in a distributed AGI. The structural fundamental similarities here are truly breathtaking. And this brilliantly illustrates what we've been driving toward. This is the core thesis of everything we've explored today. AI now adapts for shortcuts to improve its efficiency in integration, understanding, and interactions. It is based more now on visual cues, almost the same as gaze, favia, and saccades complement for the brain logics. AI is actively right now adopting the visual logic of our own biology, and that is exactly what will build the superway to true intelligence. Which leaves us with an incredibly provocative question to ponder. Where will this shared contextual superway take our collective intelligence next? We are literally watching the real-time convergence of ancient biology and cutting-edge tech unfold before our eyes. I really hope this explainer gave you a clear, structured, and exciting view of the incredible path ahead of us. Keep exploring, keep questioning, and I will catch you next time.